And now let's move on to the last presentation in this block. You are all very happy that you have, still brighten up and managing to keep your eyes open. I know it has been a long day, but there's not. We're in the final stretch. So now, next up is Project Ditens, Energy and Heat Transition and Digital Twin of Vineyards. So let's welcome head of the HLRS Visualization Department, Uwe Wössner. Welcome.
Talking about stretch, you should have made them get up again and wake up. So, let's see. Oh, my mouse is not working. Ah, it is. Perfect. Let's go on. I changed the title a little because I realized I thought we were a small family here, and now it's a bigger crowd, and I think I have to start from the beginning. So this is the outline of my presentation. I want to start with where I'm coming from. My name is Uwe Wössner. I'm heading the visualization department at HLRS, which is a national supercomputer center in Stuttgart, Germany. We have big computers, much like Cinica in Italy. Our big one is Hawk, which is currently running about 5,000 nodes. It's a big system. It also has a lot of GPUs to do your AI training, if you will, or doing simulations. The number that's not on there is its power consumption. 3 megawatt of power is required to run such a machine, which is a lot. We'll probably come to this later on. And this is the first time I can show this picture. That'll be the next system coming up. It's being installed probably end of this month. And some numbers for those. You can read that up later. We're developing software to deal with simulations coming out of supercomputers. And we developed 2 systems. We don't have to go into detail. The first one is Covise. The second one is Vissel. Both do the same. Vissel is the new system, and it runs in parallel and can process huge amounts of data on supercomputers and provide them to end users on the desktop. What's the important takeaway is that the software that we develop is open source. So if you like any of the applications that I will come to and you want to use it yourself, you can just download it, install it, and run it. Both the systems use the same virtual reality software systems called OpenCover. So from time to time, you'll hear Covise, Vissel, and OpenCover. So what we are focusing on is virtual reality in all of our work. And if you hear virtual reality today, you probably think of head-mounted displays that you put on and walk around in your 3D world with a game engine. We do it a little different. We use projection-based or screen-based virtual environments. The advantage there is that you can be a group of people going into that space, and you share the same virtual environment, which fosters collaboration, and that's what it's all about. You want to present your work, you want to share data, you want to share information, you want to talk with each other and develop solutions in that virtual world, and that's why you need to be able to talk to each other. You can't do that with head-mounted displays. This is a picture of our cave, our virtual environment. Back in Stuttgart, it's a room with 5 walls. We project on the ceiling, the floor, and all the walls, and then you stand inside your data and can analyze that. You can also do that with computer screens or LED walls. This is a picture from Cal IT in San Diego, and Jürgen, the guy there, he took 70 4K TVs, arranged them in a sphere, well, that also works. It's 3D TVs, obviously, so you can have your 3D virtual world. in there. But you have to generate 140 images. That's also a little challenge. So I'm coming from engineering. I'm a mechanical engineer by profession, and that's what we mostly do. I'll fast forward. This is combustion in a boiler of a coal power plant. But just to show you what we normally do, we have simulations. The combustion in that power plant was simulated, and you can go into your virtual environment and interact with the visualization. You can move around, cuts, analyze streamlines, create isosurfaces to represent scalar values, represent the flames in this simulation, and thus interactively analyze huge amounts of data. So that's where we are coming from. In order to create these simulations, we need data, boundary conditions, buildings, for instance, in this case. So we bought a laser scanner, and we can scan the power plant, scan the boiler, then derive a computational mesh to the simulation, and continue from there and analyze it in 3D with all that. This technology helped us also when going towards architecture and building and construction. These here are applications that you're probably more familiar with. This was a building that was developed for Adidas, an office building, and here you see how it's being used. You're doing like a 3D walk through your project, like on the construction side, but the big advantage is you can do that early on before concrete has been poured and when you still have the chance to do modifications. And it's always groups of people joining that virtual environment, and then you immediately lose about the sense about the technology. That's not important, and the quality of the pictures, and that's really not it. You immediately see how people start to talk about the building, the content in this case. And we continued that development and added a direct link to a BIM system. We use Revit for this. And in the video, you can see how Joachim, a colleague of mine, is moving around a window in 3D, and the 2D CAD is adjusted accordingly. So no matter whether you're doing modifications on the desktop, in your CAD system, or in the virtual environment, both are synchronized, and you always have the current state. And you'll see applications of this technology throughout the next applications. We can also run this in collaborative mode. So if you're not all at the same place, you can join virtual reality environments through the network. And others would call this metaverse, but whatever. We call it collaborative virtual environments. You see an avatar, that's the little glasses, the hand floating around. That's the other person. You can see where he's pointing at, what he's doing. I'll fast forward real quick. So here you see the other person placing a marker at the stairs. You can walk through and work with the virtual environment from any site. And then if you have a building, it's not enough to just walk through your geometry and have a look at it, but we also want to see the functionality of the building. This here is an example where we simulate airflow around an elevator. This is the Thyssen Multi project, a cool elevator system. This is a structural simulation on the same elevator, and we also did fire simulations in a building with this elevator, for instance, and so on. And that's the final visualization. You have a 3D BIM model, as we've seen earlier, can be directly streamed from Revit. You can walk into the building, and let's fast forward. Here we go. And in the building, you have a digital twin of your elevator, which is working. And there's the actual control of the elevator that's moving all the parts. So you can step into the elevator, keep the one door open, all the other cars in that elevator will react on that. They will queue up until you release it and go up. It's a cool elevator system. It doesn't hang on a rope, but it runs on rails with linear motors, so you can have any number of cars in one elevator shaft and thus transport many more people with the same floor space. Next one. And from a building, we immediately saw, well, we have to grow. A building is not standing on its own, so we went into digital urban twins. First we started with little quarters, and in the end we ended up with whole cities and regions. This is a picture of Herrenberg, a little town nearby, and again you see different data sets within. So like streamlines representing airflow in this building and so on. I'll come to it later on. This is another digital twin of a city quarter that's in Hildesheim, where we have a BIM project. That's this one here. These two buildings are Revit files, and the rest is just a 3D digital city model that gives you context to this. We use this data set in public participation, and it was really interesting to see when people were able to walk through that new city. It's a former military base. The US went away, and this whole area of town was developed as a new living area, and people were afraid it would get a just high rises and not pleasant to live in. And once they saw that there's green in between, that there's trees that you can walk through, and you see over to the other side, to Old Town, they all agreed that it looks much better than what they envisioned from all the renderings that have been published and all the documentation that was available. So this is pictures from our digital twin of Herrenberg again. So you see airflow representing the dispersion of fine particles from the street. You see a BIM project in the center, and you see a network analysis, street network analysis to the right. We also added traffic simulation to it, and we added social data from, we used a mobile phone app, distributed this within Herrenberg, and people could give information about how they like places. They could leave text messages, they could leave pictures, and information on how they feel in town. And this is also available as a data set within that digital twin. Another current project is a water power project in the near area. You see it's a huge area. We have the digital model of the landscape. We have trees. We have simulations in there. I think I have we also, I think that's an old presentation. Anyway, we do simulations on like flooding in here. So you can take the 3D terrain, do a shallow water model, and see how how the water flows through the area and what will be destroyed. This is a worst case scenario, and it helps people to not be afraid of uncertainties, because they don't know what could happen, and if you can show them what's the worst case scenario that can happen, it's typically quite okay. Come on, oops, I have to go back one. Here, this is current pictures from last month. They are digging holes, so construction is going on, and I'm quite happy with that. I'm missing a slide here, I don't know why, but let's go back to here. So down here you see some colors. That's data from a construction noise simulation, which was very important during public participation. So we used this 3D model to present the project, the power plant, all the ducts that have to be dug into the mountain, the water turbines, the storage lakes, and so on. We presented this multiple times to the public in small events, like in small groups, but also in huge events with a huge tent and 3D projection, like in a 3D movie theater, where a few hundred people living there were able to participate and see the digital twin. And we had a lot of questions that could be answered because we could interactively navigate to that position in question. So say they wanted to know whether it'll be loud during construction at their home. We would just ask them where they live. We would fly there. You would see what you can expect from a noise level and what you would optically see. And it was really helpful. Yeah, we've seen these. That's our digital twin of the city of Stuttgart. It's larger than the city itself. It extends to a lot of the surroundings, and we have weather simulations from a standard weather code, WRF, which has been extended. There's a publication if you're interested, WRF Chem. It has been extended to support the chemistry in the atmosphere to be able to simulate fine particle pollution and NO2 distribution in the atmosphere. And it's a fine grain simulation. I think the mesh resolution was 10 meters, but on several square kilometers of size. And you can still interactively analyze that data. You can walk through that city and go to any place and start streamlines, see what the airflow does around a certain building, and how the effect on the climate is. This is just a little movie that shows you how this digital twin of Stuttgart looks like in detail. Let's fast forward. And we can do studies in that 3D model then. We can go down to that place. We have a driving simulator, a Porsche car that you can use, a bicycle simulator, and this wheelchair simulator that you can use to try out different traffic modifications in your virtual world. You see cars driving around and pedestrians walking. This is a simulation that's running in the background. We use Sumo to do that traffic simulation. And currently we are working on simulating setting up a Sumo simulation for a whole Stuttgart and its surroundings, which is quite a challenge. So if you're doing that, I would be interested in collaboration. This here, let's see, is not working. What a pity. That's really a pity because this would show a data set of all of Estonia, of Tallinn and Estonia. That's a pity. Let's see if the next one is running. But no, that also is not showing up. What a pity. So I downloaded the open data from Estonia. So you can fly over whole Estonia, go to every city. You have the 3D city model. I added all the wind turbines and the power network. So you see the power line poles. We have that really nice 3D model of Tallinn Old Town also in there. And we added some BIM projects through Revit into the same 3D model. And unfortunately, the video doesn't work. Another current project we're working on is our Vineyards on the River Neckar. The River Neckar runs through Stuttgart, and on the side of the river, there's a lot of steep vineyards, and they have to be farmed manually, which is a huge problem. Only older guys would do that, and all the young ones don't want to work on that anymore, so some of them a lot of them, unfortunately, are not worked on anymore, and they get deserted, and we want to do something about it. So this is the base data that we have, and we can derive data from that, like solar information, or we can also do flooding simulations, as you've seen on that, and gravel and traffic simulation in there. What we started this year was we fly the area with drones to get higher resolution imagery, and from that we can assess the dry walls that are in between the vineyards, and we can assess their number and their status, whether they are still okay or whether they have to be repaired, like you see a little broken area in here. So that's current work we are doing. There's a new bridge that will be designed over the river in the same area, and we're also working on that. Then Ditens is another project we just started, which is focusing on the energy transition. So we are building the models of all the electricity networks and gas network and heating, district heating networks. And we want to tackle the building level, the street and quarter level. We'll probably end there and not go to full city models within this project. We'll probably end at the quarter level. But we're focusing on heat transition, so how to get rid of a lot of the gas demands that we still have for heating buildings. Currently, so the HLRS again is working on virtual reality visualizations in order to do public participation and bring people together to discuss which option of transformation is actually the best to implement, because there's not that one solution that fits everyone. It's really specific to a certain building or area, what's worth doing, whether solar or solar heat or heat storage or cold storage, whatever you need. And we're currently doing live data access to databases and visualizing that in our 3D model. This is our university campus and the local district heating in here, and we're simulating that right now because we are building a new server room for a new computer that requires more energy, but we will feed all the cooling energy or the heat that the server produces that would otherwise need to be cooled. We feed it into our district heating in the future, and we want to simulate that. Now, I want to show you one project in a little bit more detail, which is Südlink. It's also part of the German energy transition, and it is about a power line running throughout all of Germany. It'll be 700 kilometers long, and it's going to bring down wind energy to the southern states where there's little wind turbines. And up there we have a lot of wind turbines, but little industry. So the demand is not there. Sometimes we had to shut down wind turbines up in the north and fire up gas power stations in the south because there was demand here and the power was up there. It'll transmit 4 gigawatt. That's also a huge number. 700 kilometers. This is the cables. They are huge. They carry 500 kilovolt, 500,000 volt. And it'll be all buried. So it won't be a standard power line above ground, but it'll all be buried, all the 700 kilometers. And we are especially focusing on the crossing of the river Elbe. That's this place here. And this is the architectural rendering. It looks nice, but it doesn't help you. That's why we built up the BIM model and visualize that in virtual reality. And here you can actually go into every room. Every door is there, every facility. You have restrooms, whatever, right? And it was important because we had, I'll show that later, we had so many meetings with all the stakeholders in that process, and we changed so much within that model that wouldn't have been possible without these meetings in virtual reality. So oops, damn it. You see the cable coming in from the right. It goes down into a tunnel and over to the left, and then it goes 500 meters underneath the river Elbe, and on the other side it comes out again. There's the same building, just inverted 180 degrees. We also added support for building phases. So you can see the individual steps in which these are just 3 of 20 of the building steps. You can click through them and see how the different building phases go on. And then we had sessions in that virtual reality environment with all the different groups from the standard BIM team to the cable manufacturing, to HVAC, to safety, health and safety. The last one was with a team that builds the train that services the cable during runtime. So plenty of different tasks, and with each of these, each meeting was about half a day. So we typically did 2 meetings on a single day, one in the morning, one in the afternoon, and they all used this virtual environment. As you see, you walk through that building. He had a sheet of paper in his hand where he took notes on what was discussed and what will be changed. Some of it, we could change it immediately in the BIM model, and you would see the change, and here we go. That's how we're gonna modify it. And some of it was just noted down and to be worked on later on. And again, it was always many people at the same time discussing about details with each other. And we also used it for public participation. This was during the planning approval, and we had high-ranked politicians come in, but also kids and people that live in Glückstadt up on that river, and they were all happy to actually see what's going on and what will be built for the next 5 years. Another important politicians with the 3D visualization of the tunnel and a run through that tunnel in VR behind them. That's pictures from the construction site, so they also started, and this was me. I did some 3D laser scans on site and took some drone footage that we now added to the planning model to see where things differ and where we are right on track. And I want to show you some augmented reality as well. That's the engineering part that we often do. Like this is like a wind tunnel, and you can visualize your simulation results, like the airflow around the car, right on top of the vehicle. We're from Stuttgart, so it had to be a 911. And where are we? Here you can interactively select where you want to see streamlines and analyze the flow in detail. But you can also apply this to buildings. This is a tower to test the elevator that you've seen before, and this is wind flow around the tower, so strong wind, currents, simulation. But we also applied this to physical 3D city models, and there you can visualize how different options in modifying your city could look like. And this is the Südling project. You see the airflow through the building in a physical model of that building. This airflow is used to cool the cables. And yeah, we can either display this in the virtual world in 3D or here in augmented reality live on a physical model. That's it.
Thank you, Uwe. Am I pronouncing it correctly?
Yeah, perfect.
Or how do you say it?
Uwe.
Uwe,
That's
okay,
perfect.
Uwe. So does anybody have any questions for Uwe? Oh, I see one hand there, and the microphone is right behind you. Oh.
Okay, I have one question about like the visualization that you made of like the cable that is going underneath the river. So you said that the citizens also went to like interact with it to see how it would look like.
Yes.
But does the visualization also show like what the impacts will be on the environment, like in the surrounding areas, because you kind of decide what you want to show to the citizens living there?
Yes.
In the visualization.
And it highly depends on the owner of the project, how open they are. Here Tenet is quite open, and they actually presented like the cooling airflow, and there were immediately questions, what do you do with all that hot air? And well, it could be used, for instance, for farming. If you have greenhouses, you can heat them up and get more food out of there. But on the other side, what they didn't show, what I wanted to show, is a construction noise simulation. And unfortunately, I didn't get that data, so I couldn't show it. In the other project, in the water power project, we did show it, and it was good, because right now they are having issues with construction noise. They are above threshold in one of the neighboring buildings, but because we did show this early on during all the public presentations, people were informed it's going to be loud in that area. You could see that, and it was told, and yeah, that was a good thing for them. Also, there were 2 other water power projects in southern Germany that were planned during the last few years, and all of them have been cancelled because of protests by the people around it. They didn't like it, and they got cancelled. And the energy transition will not happen if we don't get projects done, right? If we're always saying not in my backyard. And here it worked, and I think part of this is because the communication was very open, was good.
Okay, thank you.
Okay, thank you. Let's give another round of applause to Uwe.